Well, welcome back to part two of economic efficiency ratios. In this part, we're going to look at different costs for different levels of output. So when you're analyzing the problem, make sure you check the output to make sure they're the same or different. When they are different, the degree of difficulty increases just a bit. So the most economically efficient method in a situation involving different costs and different levels of output is defined as the economic efficiency ratio, which the economic efficiency ratio is equal to the value of the output divided by the cost of input. Once again, the value of output divided by the cost of input, the ratio of the value of the output to the cost of the input. The higher the economic efficiency ratio, the more efficient the method. Please underscore, highlight that the higher the economic efficiency ratio, the more efficient the method. So here's an example. It's a continuation of the previous one, but here we're going to add in the value of the shirts. The price of capital is $20 and the price of labor is $10 and the price of a shirt is $5. You'll recall from the previous example, the value of the input for method A is $7,000. So the value of the input for method C is $9,000. And here you see the equations as a reminder on how we got those numbers. Here's method A and method C now. The capital used by method A is 100 and the labor is 500. For method C, the capital is 50 and labor is 800. Method A produces 10,000 shirts a week. Method C produces 11,000 shirts a week. So the value of the output for method A is $50,000, the $5 times the 10,000 shirts that are produced. And the value for method C is $55,000. Once again, that would be $5 per shirt, 11,000 shirts, which is equal to $55,000. So using the ratio that we saw, the economic efficiency ratio, the value of the output divided by the cost of the input. So for method A, that would be 50,000 divided by 7,000, which is equal to 7.1. And for method C, it would be 55,000 divided by 9,000, which is a 6.1. Method A has a higher economic efficiency ratio. It is economically more efficient than method C, because what this output of 7.1 tells us is that for every $1 of input, the company receives $7.10. Method C, for every $1 of input, that method is only returning $6.10. So obviously that extra dollar is attractive to the company. They will select method A. So here's a problem for you. You are contemplating going into business to produce CDs. You are faced with the methods of producing CDs as shown below in the table. The price of capital and labor are $5 and $6 respectively, and the market price for the CD is $10. Which method should you choose? So method one uses 10 units of capital and 6 units of labor, produces 24 CDs. Method 2 uses 15 units of capital and only 2 units of labor and produces 25 CDs. So the potential solution is the choice between method 1 and 2 will be made on the basis of their relative economic efficiency ratio. So the value of the input would be 10 times $5 plus 6 times 6, which equals 86. And the value of the output is 24 times 10, which is $240. So the value of the the value of the output divided by the value of the input here will return $2.79. For method 2, the value of the input using the same formula is $87, and the value of the output is $250. So once again, the economic efficiency ratio, the value of the output divided by the value of the input, was going to return $2.87. The first one returns fewer dollars than the second one. Therefore, you will pick method 2 as the one that the company should implement. Thank you very much. And that is the end of economic efficiency ratios.